the written section video. For the first question, be dealing with the chi-squared test. So I found out the total number of all of the F1 plants to be able to use that to find the expected value. And these are all the observed values. So I made a hypothesis, and I then calculated my chi-squared value. Here's my hypothesis. I found the probabilities for each of the plants happening, and I got my observed versus my expected, which is found from using my probability times the number of the whole population, and this is what it should be, the expected values for a 9 to 3 to 3 to 1 ratio. And my answer was 183. And so we will reject the null hypothesis, as our critical value is 7.8, and we have gone way above that. A new hypothesis that our plants demonstrate another pattern of inheritance, possibly X-linked recessive inheritance. We don't know for sure. That's why we're performing hypotheses to try and figure it out what's going on. In 2, it talks how it says that woman is heterozygous for Huntington's, and it's a dominant autosomal lethal allele. And so when she crosses with a male who is just doesn't have Huntington's, then the probability is that half of their offspring will have Huntington's and half of them won't. And the first question is, all 6 of the children will get Huntington's. And so I put the probability as 6 and raise it to the probability of the children of one child getting Huntington's, and then I raised that to the 6th so that it would show the chance of all 6 of them getting Huntington's. For the second question, it asked if they'll get 4 unaffected and then 2 affected children. And since the order doesn't matter, we can use the binomial expansion equation, in which I did right here, where this is n, the number of the total children, and x, the first one, or it could be the other one, doesn't really matter. And then n minus x, this is the probability of x happening, this is the probability of the other one happening, and this is the number of the other one, which is 2. And I figured that out, and this is what I got for my probability. For C, they wanted to know is the probability that the first 3 children will be either all affected with Huntington's or all unaffected. So since there's the or here, we know that it's going to be a sum rule. So we got to add the probability of them all being affected or all unbeing affected. The first 3, excuse me, being affected, not all of them, and then the rest of them being unaffected. So I found out the probabilities of each of those and add them together, and we get this. For the next few questions, it'll be trying to figure out what the inheritance pattern is, looking at pedigrees. And for the first one, we can see here that the male's affected, that all the females are affected. So we're going to say that this is an X dominant, whereas when the males and the females mate, all of the females' daughters of the affected male will be affected. Now this could happen with autosomal dominancy, but there's only a 1/16 chance of this happening, so that's why I chose X-linked dominant. And for question B, I chose that it would be not X-linked, it would be autosomal dominant, because it appears in every generation. And now it's not going to be autosomal recessive, because if this one was affected, then none of these individuals would be affected in the Roman numeral 2 generation. And it's not X-linked because there's this male which gives this male affected. Affected males don't make affected males for X-linked characteristics. For question C, this is an example of X-linked recessive inheritance. And I know this because more males are affected than females, and all the females are carriers. Like this one would be a carrier, this female would be a carrier, and this female would be a carrier. For number D, I also said it was X-linked dominant because all of the females are going to be affected 100% for this if there's an affected male. All right, so for question 8, it says American hedgehogs have 90 chromosomes in a typical diploid somatic cell. And there's going to be, for part A, there's going to be 2 sets of chromosomes because it is a diploid organism. And how many tetrads are going to be found during prophase 1? Prophase 1 is where crossing over happens. And crossing over happens between homologous chromosomes. So since there's 2 homologous chromosomes and those are going to be connected, that'll make a tetrad. And that'll be half the number of chromosomes that are found in the cell, which would be 45. How many sister chromatids are found per cell during metaphase 2 for part C? There is going to be 90 sister chromatids found per cell because they don't separate yet until anaphase 2. And there's 90 because at this point in meiosis, there's 45 chromosomes per cell. And that kind of answers the next question. There's 45 chromosomes per cell during prophase 2. Now in reality, there's 90 chromosomes, but only 45 of them are going to be unique chromosomes, whereas there's 90 sister chromatids. All right, question 5. I like this one. It was fun. So there's a tetrahybrid cross in pea plants, and they give you which ones are recessive and dominant. And so I went ahead and my work, sorry, let me find it. I made this table right here to show the probabilities of each of the individual traits, their probability of happening. That way, if I get a certain type of genotype that they want me to find, then I'll be able to just do the forked line method and just times them through without having to make a huge tree. So the first question, they wanted the probability of getting the 2 little t's, 2 little r's, and the big Y, little y, and then 2 little a's. And so they just want yellow. That's what it is. And that can only be for yellow because there is a little y, big Y, little y, which would make half little y and half little y's. That because if it were like this, then you could have 2 big Y's, but since it's not, then you can't have 2 big Y's. And I found the probability is going to be 1/64. And then they wanted the probability of a totally heterozygous individual, and I just used my table and calculated it through to get 1/16. And the next question is, what is the probability that the first 5 offspring will have this particular genotype? Probabilities in from my table, and then raise it to the 5th because it's going to be timesing it by itself 5 times. And here's my answer right here. For part D, they wanted to know, it was an or question, so they want to know if the probability of this happening or this happening. So you got to add them together after you find the individual probabilities. And I did find the individual probabilities and add them together, and this is what I got. All right, thanks for watching. I hope it wasn't blurry this time. I'm having trouble trying to not have blurriness with my screen share. I'm not quite sure what's happening with that. So this is the second time I've recorded, and I tried to make it a little easier to see. I hope it helps.